Okay, this is the videos for Module 5, and this is all on hypothesis testing. What we're going to look at today are the steps for hypothesis testing, a couple of hints to help you with each step, and then I'm going to do 3 examples, one of each different type. Now, Chapter 8 hypothesis testing is all about testing around the mean. So you're doing a hypothesis test from a mean. The first thing I'm going to show you is your hypothesis testing steps. Okay, this is the 5 major steps you do for any type of hypothesis testing. Number 1, always state your null and your alternative hypothesis based on your problem. Okay, your null is H sub 0, your alternative is H sub 1. Some books call this H sub A. Not a big deal. Number 2, calculate or find your test statistic. Now, your test statistic when you're doing Chapter 8 hypothesis testing, which means testing about a mean, is found this way. Now, notice this is the formula for a z-score, but it looks a little different than what we've been doing. It's your mean of the sample minus the mean of the population over the standard deviation of the population divided by the square root of your sample size. Very careful how you type this into the calculator. What you really need to do is make sure this top part is in parentheses and the bottom part is in parentheses as well, or you're not going to get the right answer. Okay? Number 3, pick a method, and I'm going to show you both, the p-value method or the critical value method. Number 4, do your comparison. I'll explain that when we get there. And number 5, state your conclusion. Okay, these are the 5 major steps. Now, a couple of hints to help you with each of these steps. And you'll also find this stuff in your notes. Okay. Okay, the first thing is, as far as how you state your null and your alternative hypothesis. You're going to determine if the test is right-tailed, which you'll see something about more than this, left-tailed, less than, or two-tailed. It'll say like different from. That's your next thing you're going to do once you state your null and your alternative, because that's going to determine how you do p-value and how you do critical value. Very, very important. No other hints for number 2. I should already show you the formula, and we'll show you how to do that. Some more hints for number 3. Now, number 3 was pick your method. If you're choosing the p-value method, then you find the p-value using the methods we discussed in Chapter 6. Okay, meaning you're going to do like normal CDF of that number to 1,000 if you're going to the right, or normal CDF negative 1,000 to your number if you're going to the left. If you're two-tailed, it's a little bit different. So we'll talk about that too. If you're using critical value, you use inverse norm, also from Chapter 6. Okay, so these are some hints for 1 and 3. Now, step number 4 is to compare. And you may be asking, well, what is it that we're comparing? Okay, well, in step number 4, if you're using the p-value, you're going to compare your p-value to your alpha, which is your significance level. P-value always goes on the left, alpha goes on the right. That's very important, or you'll get the inequality going the wrong way and you'll get confused. If your p-value is less than alpha, you reject. If it's greater than, you fail to reject. All right, if you're using the critical value method, use the critical value to draw a rejection region. So you're actually going to draw a normal curve. If the test statistic falls in your critical region, then you reject. If it doesn't fall in your critical region, then you fail to reject. And this is always talking about, when I say reject or fail to reject, you're talking about the null hypothesis. That's what you always reject or fail to reject. Notice that fail to reject, I don't say accept, because you never really accept a null hypothesis, because different data could give you different results. All right, so let's see how to do all of this. All right, here's our first example. Okay, it's called red blood cell count. Now, when you're looking at this problem, there are several important things. A lot of people say, well, what is it that I want to get from this problem? Or what is it that I'm trying to look at? So what you want to do is make sure that you know what key phrases you're looking for. All right, number 1, okay, you want to find your sample size. Very important. This is a simple random sample of 50 adults. Is obtained and each person's red blood cell count is measured. The mean is 5.23. This is the mean of the sample. Very important. The population standard deviation is 0.54. Use a 0.01 significance level remember that's alpha, to test the claim. And notice I put claim in all capital letters. I did that for a reason, because it's very important to figure out where your claim is going to go. That's how you set up your alternative and your null. So you're testing the claim that the sample is from a population with a mean less than 5.4. Okay, that is how it's going to help you to set up your alternative. Alright, so we're going to work through the 5 steps. Since it's less than, this is called a left-tailed test. Very important. Alright, so what I'm going to do is I'm going to kind of summarize the information I have. Okay? Alright, first of all, I have n is 50. Alright, my mean of my sample is 5.23. Standard deviation is 0.54. Alpha is 0.01. And the mean of my population is 5.4. That's what's given in my claim. Alright, so the first thing I'm going to do is set up my null and my alternative. Okay, now, when you're doing this, there are 3 different ways that you can set up your hypothesis. You need to go back and look at your notes to kind of review that. But HO is always equals. Always equals. That will never change. So it's going to be mu equals 5.4. H1, your alternative, is always the one that comes from your phrasing in the problem. Ours said less than. So we're going to do mu is less than 5.4. Okay, this makes it a left-tailed test. And that's extremely important when we start doing our work. We want to make sure that we know what kind of test we're looking at. Okay, so that's number 1. Number 2 is to calculate the test statistic. Alright, so we're going to do mean of the population, mean of the sample, minus mean of the population over standard deviation divided by square root of the sample size. Now, if you're going to do this in a calculator all at one time, make sure you put parentheses around both the numerator and the denominator. And since this is a left-tailed test, you should get a negative test statistic. All right, and I'm getting negative 2.23 if I round to 2 decimal places. Okay, that's my test statistic. This is also just another z-score. This is going to be important later on, so we need to keep that in mind. Alright, so that's step 2. Okay, step 3, we are going to figure out which method we're going to use, and I'm going to show you both. So I'm going to start with the p-value. Now, since this is a left-tailed test, I'm going to do normal CDF negative 1,000 to negative 2.23. This is going to give me my p-value. Notice I did CDF because it's a cumulative approach. We don't do normal CDF or PDF or anything. Alright, so normal CDF, negative 1,000, comma, negative 2.23. And my p-value is 0. I'm going to use 3 significant digits. So 0, 1, 3. Okay, so that's my p-value. That's all you have to do if you're using the p-value method. Okay. Now I'm going to finish this and do step 4 with the p-value, and then I'm going to come back and do 3 and 4 with the critical value. Okay, so here's step 4 if you're doing p-value. You're going to compare your p-value to your alpha. Okay, well, which one is bigger? The p-value is larger than alpha. What does that mean? Well, if you remember, if it's less than, then you reject. So if it's greater than, you're going to fail to reject. So I'm going to fail to reject my null hypothesis. And I just abbreviate this, fail to reject HO. So FTRHO. If I'm rejected, I'll put RHO. Just kind of a shortcut. And then step 5 is to state your conclusion. Now I'm going to wait to do the conclusion until we've done both methods so you can see the difference. Alright, so that's p-value method. Now, for critical value method, I'm just going to repeat steps 3 and 4. 1 and 2 stay the same no matter what method you choose. Okay? Step 3, if you're doing the critical value. Like I said, if you're doing the critical value, what I told you out in here is to go ahead and use inverse norm. Well, you may say, well, what do we do an inverse norm of? Well, you look at alpha, and you want to figure out, okay, what is alpha? Well, alpha is 0.01. Okay, and since this is a left-tailed test, I'm going to use exactly that. If it was a right-tailed test, I'd want to subtract that from 1 because I want the upper end. So I'm going to do inverse norm of 0.01. This is going to give me my critical value so that I can draw what we call a rejection region. So inverse norm 0.01. I'm going to get negative 2.33. Okay, that's my critical value. Notice it's not my test statistic. It's very close, but it's not my test statistic. Okay, so I'm do that. Once you get your critical value, that's really all you're going to do, and then you're going to draw your region. So step 4, I'm going to draw a normal curve. Okay, I'm going to put this on my curve, so you know this is 0, negative 1, negative 2, negative 3. So I'm going to say negative 2.3 or negative 2.3. About right here. Okay, this is called a rejection region. Okay, so this is negative 2.33. Now, if my test statistic falls in that region, then I'm going to reject. If it doesn't, I fail to reject. Well, if you recall, the test statistic was negative 2.23, which is actually going to be to the right of negative 2.33. It's a larger number. So I'm going to say it's about right here. Okay, this is negative 2.23. Well, it's obviously not in that region because it's a larger number. So because it's not in the region, you should have the same conclusion no matter what method you pick. That's very important too. So again, I'm going to fail to reject because it's not in my rejection region. Okay, so those are the two methods. Now, step 5 is to state your conclusion. And like I said, it really doesn't matter which method you use, your conclusion should be the same. This is one way or another. There's lots of ways to word a conclusion. I'm going to say there is not sufficient evidence, or you can say enough evidence, to support the claim that the sample is from a population with a mean less than 5.4. Okay, there is not sufficient evidence to support the claim that the sample is from a population with a mean less than 5.4. Notice I'm saying not enough information to support the claim. Well, if you go back to the beginning, where was our claim? Well, our claim is actually in your alternative hypothesis. So because I'm failing to reject this, I'm saying that this could possibly be true, so that I know that this is false. So I'm saying there's not enough evidence to support this, which is what we're saying in our claim. So again, there's not sufficient evidence to support the claim that the sample is from a population with a mean less than 5.4. Okay, this is a left-tailed test.